Hello and Assalamu alaikum. This is Zafar Khan. I'm here with the lecture 3 of logic gates. So this particular lecture is about how to draw circuits and make equations and expressions out of it. How to represent the circuit in the form of mathematical equation and logic expressions or Boolean expressions. All right. So let us see. Let's say I've got this circuit. So what is circuit? Circuit is basically combination of gates. All right, so when we combine gates for some purpose, it is said to be the circuit. So let's say I've got OR gate, then I've got AND gate. There is one input which is A to OR gate, and there's a copy of that A goes to AND gate, and then there is B input into AND gate, and then there is a copy going into OR gate. From OR we have NOT gate, and then I have OR gate. Then this is output. So you can see that this is a circuit, but this circuit has got three issues. Number one, actual shapes of the gates are not made. Number two, the lines are crossing. We will avoid that by using a bridge. When one line crosses another line, we will use the bridge. And thirdly, we will not use any of the diagonal lines. Instead, we will try to make use of just vertical and horizontal line. So let's first draw the proper circuit. Okay, so the proper circuit would be, this is OR gate, this is AND gate, we will be making use of horizontal and vertical lines, and then this is bridge, and this is basically the input for OR gate B. So you can see that A is going into AND gate as well, and B is going into OR gate, but there's a bridge and the lines are horizontal and vertical. Then output of OR gate goes into NOT gate, and then we have got another OR gate at the end. Try to make input lines a little away from the corners of the gate. That makes the whole thing very clear. And then we have the output. So this is the proper circuit for this improper way of drawing circuit. All right. Now, how to interpret this proper circuit into equation, mathematical equation or logic or Boolean expression. So let's see. So this is basically OR gate. Whatever that I'm writing in yellow is rough work. This is AND gate represented using multiplication. This is NOT gate, which is using basically an inverse or prime, and this is OR gate. So what basically happens, look at the board, what actually happens that A is being added to B. So this is A plus B. Remember to put a parenthesis, a small bracket after each and every gate. That will make sure that every gate would have only two inputs, and the complication of the equations will be resolved automatically. So this A plus B goes through NOT gate, and in that case now we have A plus B whole NOT. So remember that whatever that gets into the NOT gate will inverse it. All right, the use of individual A and B is now gone. Okay, so those A and B are basically in this OR gate, and then the result of the OR gate goes through the NOT gate, and then that goes further. Now at this particular gate, the equation would be AB, and this A and B will go to the final gate. So this would be A plus B coming in from the top, and this is itself is OR gate, and then we have AB. Then we have to put another bracket for this OR gate. So every time you get out of a gate, you have to put the equation, which is the output of the circuit or the gate, into a new set of parentheses, and the whole thing will be assigned to X. So this is basically the equation that is representing this particular circuit. X is equal to A plus B whole NOT plus AB. Now how to write logical expression out of it? Logical expression would be X is equal to 1 if, this is a must part for every logical expression, if, you see, this NOT gate in logical expressions come before the bracket. So right after the first bracket we will write NOT A or B, or A and B, bracket over bracket over. So you can see yourself A or B whole NOT, which in the expression form will be not A or B. This is OR, and this is A and B. So remember, in logic or Boolean expression, don't use any mathematical way, or in mathematical equation, don't use any logical way. So let's create another question. Now, the second one is not. We have A going as input to the NOT gate, and then we have AND gate. We have OR gate. So this is that circuit from which we have to create actual circuit. So remember that this is just this is just for the practice. This is not part of the syllabus. So what if you would have to make, you would have to make a proper circuit, and if you are given a circuit, you will always be given a proper circuit. So this is just for the practice that you should be able to draw proper circuits. So let's first convert it. This is NOT gate. This is AND gate. This is OR gate. This is NOT gate. And then we have exclusive OR gate. All right. So this is basically a proper circuit. Now, let's make the equation out of it. So this is A naught. Remember, we don't use parenthesis for NOT gate. So then this A naught goes to OR gate. Over here it is A and B. Now you see that we have one T junction. It means that A and B would go here, and A and B will go further as well. So in final mathematical equation, we will see A and B twice as it is being copied. So over here it will be A naught, this is OR gate, plus AB, or then we have to put another bracket of OR gate. So when this passes through NOT gate, the whole result will be inverted, and then this would go further into exclusive OR gate. So this is A naught plus AB whole naught. Now this A naught plus AB whole naught will go to the exclusive OR gate, and that would have the next input AB from there. Okay, so this will become X is equal to A naught plus AB whole naught exclusive OR AB. So this is our mathematical equation. So how we would write this now with Boolean expression or logical expression? That will be X is equal to 1 if bracket start, and this not will be before the next bracket. Not bracket start, not A, or bracket start A and B, bracket over, exclusive OR. Yes, you can write it in multiple lines, does not matter. A and B, bracket over. So this is how we create proper circuits and read them into equations, and from equations or the circuit we create logical expressions or Boolean expressions. Now I'm going to make 3 more circuits for you to practice, and you make proper circuits out of it, and then mathematical equations, and then logic expressions. NOR gate, NOT gate, NAND gate, A, B, and then AND gate. Then we have another number 4. This is with 3 inputs: OR gate, AND gate, A, B also going to OR. There's a copy for B in AND gate, and then we have got C. Then we have exclusive OR gate, and then we have another AND gate. Alright, so since this is the circuit with 3 inputs, I'm going to solve it. You just check. How would I draw it? OR gate, AND gate, A as input to OR, A B as input to OR, the copy of B goes to AND gate, and then we have got C. Then we have exclusive OR gate that has input from OR and AND gates. Then we have got AND gate, and input from C is coming in. This is basically X. Now mathematical equation for this, we have A plus B. For this we have A and B. For this we have an exclusive OR in between and then a new set of parentheses. And for this we have AND C, a new set of parentheses, and the whole thing is being assigned to X. And then logical expression, X is equal to 1 if A or B, exclusive OR A and B, bracket over and C. So this is a circuit with 3 inputs. So now I am going to make another 2 circuits for you to practice. Number 5, this is AND, this is NAND, A, B and C. And then we have got this NOT. The output of AND gate is the input for NOT. Then we have got OR. NOT goes further, a copy goes to OR. And then we have NOR. Then we have a 6th combination of circuit, which is a little bigger for you to practice well. A and another AND. The output of NOT gate goes to AND gate. Then we have got B, and then we have C input. Exclusive OR. The output of AND gates goes to exclusive OR. Then we have OR. And then we have another OR. This is our X. So I'm leaving these 3, number 3, number 5 and number 6. You can always pause this video to check on these. So this is the lecture for how to draw proper circuits and how to extract equations and logic expressions out of them. Logic expressions are sometimes called Boolean expressions or Boolean equations as well. So that's it for lecture 3. Thank you. In next lecture, we will be creating circuits out of equations and expressions. Thank you.